Much. So my name is Darrin Miller. I'm a distinguished technical marketing engineer. I have a new title. I like this title better. I just joined something called the Distinguished Elite Hall of Fame Speaker, or as one of my friends said, I'm now a delete engineer. So I thought that was pretty good because I do backspace quite a bit. But I'm here to talk to you about Access Control App. Now that's a name of an application that we've built to enhance the access control, so the security policy within Cisco DNA Center. So how many of you guys are security guys?
I mean, some.
Ish, okay. Well, you know, all that assurance that we just talked about, well, this is going to break a whole bunch of things in people's networks because that's what policy does. And then the assurance will help you figure out what's going to happen. So in all seriousness, one of the things that we have found in our experience, Kevin Regan is one of my colleagues, is that as we go in and we look in enterprise networks about traditional segmentation, right? It's a very hard uplift for a number of reasons. One of those reasons is that we've done a great job of building cheap, fast, ubiquitous connectivity everywhere, right? So wireless assurance that you just saw with the machine learning is looking at why I don't have ubiquitous connectivity, right? Why am I getting DHC timeouts or whatnot? Whereas when you look at segmentation, segmentation's about controlling the environment and in some cases closing it down. And when we do that, we create a lot of operational expense if we use traditional mechanism. So what we've been looking at and what we have been building with software-defined access is a notion of being able to allow all of those devices the connectivity that they need and grouping them together into two general notions. The very first one is what we call macro segmentation. So if you're familiar with VRFs and extending MPLS L3 VPNs all across a university campus or across a WAN, virtual networks are in essence an abstraction of that so that you don't have to do that kind of VRF stitching box to box to box. Or from a VLAN to an MPLS 3 VPN provider. Right? This is an overlay based upon VXLAN, and it's a logical overlay that can extend through any IP network, whether that's your private network or if you use public transport, anything like that. When you need to connect those VNs, there's an implicit deny between the two, so you have to go through something. In university environments, this is typically called a fusion router or a fusion firewall. In enterprise environments, this is often a data center firewall. It's what has been termed in the past. Now it's just a fusion firewall. And it can be an abstracted function. You can have this function in a virtual form factor with an NFV. You can have it as a physical form factor, whatever it is. But it's going to connect the traditional firewalling between two CIDR blocks together, right? That's a very simple concept with VNs. Inside of it, though, we have abstractions, because inside of those abstractions, of the virtual network, we have different kinds of people within the different domains, right? Or different kinds of devices in the things domain. And whether or not they can talk to one another is typically been yes. So anybody seen the RDP worms that have been going around? Anybody? Right? Creating a lot of havoc. So one of the things that we've done and done very quickly with this technology is been able to go in, look at two groupings of employees and contractors and put in a very basic statement that says deny RDP between these two groups. And roll that out and do that in an abstracted way such that I don't have to care anymore about things that in the past I had to care very deeply about. What VLANs am I going to be writing the ACLs between? What IP addressing do I have? Do I have, new DHCP scopes if I need to create a new classification in an environment? Anybody ever deployed, ACLs on layer 3 routers and then had to add a new classification into the environment, right? Mm-hmm. What do? You create a new SVI, you create a new CIDR block, you create new DHCP scopes, and you do all of these things. And then you get to the point where you actually write the ACL. So what we want to do, and what we have done, is we want to abstract all of the policy components, so those virtual networks, those scalable group tags as we call them, and abstract them from the underlying network topology. Whether that's because it is VXLAN, there's an underlay, there's an overlay, but none of those things really matter in the notion of policy definition. The policy definition is being defined on these different kinds of abstractions that have relevance to business intent. So as an example, with that RDP worm, talking with a medical environment. And the medical environment is very simple. I want to make sure that nobody has RDP access into my medical device virtual network. So that was a very simple policy that we could write because we're building it off the abstraction, not the underlying IP addresses. They didn't have to worry, where are my medical devices? Are they in subnet 1? Are they in subnet 2? Are they in subnet 3? Doesn't matter. They just write that, and it allows very simple mobility between these constructs as well as simple policy definition. So the use cases that we typically go after with the access control app, very first one is the typical users to applications or things to applications. So as an example, in one of these different pieces of malware, the IP video camera was the source of the download of the infection because it had unfettered access into the imaging server, the image of the camera itself. So they downloaded it from the vendor themselves and then moved laterally through the environment and instigated both malware and data extraction as well as ransomware, where they grabbed different devices and held them captive. So we want to be able to control that north-south, as we call it. In addition, we want to be able to control, oops, I skipped one here. I must have hidden it. But we're going to control east-west definitions. And the east-west definitions are basically what I can control when I'm moving laterally within the network. So we can, regardless of IP address, Kevin can be on 1.1.1 and I can be on 1.1.2. I can isolate not only if Kevin's in a different group, so if Kevin's a contractor from my employee or a finance SGT, but even if we're in the same group. So we can deny that RDP moving within the same group, which is a little different than what people have been able to do out into the campus and the wireless environments and branches, right? Typically that micro segmentation, if you will, has been exclusive to the data centers, but now it's available. So if we have something like network advanced malware protection that detects some sort of breach happening, so we do detect that we have RDP malware in the environment, we can have that signaled to us from whatever threat intelligence feed that we have, Talos, plenty of others out there. And then we can signal down into the environment via the access control app, and you see a representation of what's called a quarantine system. And we reclassify Mary from a finance SGT into the quarantine SGT, and immediately, without having to change any ACLs by CLI, through NetConf, or through some sort of automation tool like NSO, we immediately apply the SGTs to the endpoint, and the policies get invoked automatically. So there's nothing that, from an operations point of view, that when you hit the button to quarantine the device that you actually have to do on the network devices. The system does that for you. So the intent is quarantine, and we automate that intent into the network. So one thing about this, so the access control app lives in DNA Center. In order to get not only interoperability, but also scale and information sharing, we send that policy, if you will, into the Identity Services Engine. The Identity Services Engine is the runtime that gives us scale. So the Identity Services Engine, as an example, can give you 2 million simultaneous endpoints connected to a single network in one administrative domain. But more importantly, when we start talking about security, inside of any enterprise or even public environment, rarely, if ever, is there a single vendor that delivers all of the security functions. So one of the key tenets that you have to have in a security architecture is the ability to share information that's relevant. So through 2 different protocols, both of which are in the IETF, SXP, Scalable Group Exchange Protocol, and then PXGrid, which is Platform Exchange Grid, we share this information to not only our firewalls, Cisco's firewalls, but also all of the major leading vendor firewalls, all of the major SIM tools so that they can do correlation. And from that, we can augment their policies or use that same PXGrid integration to trigger that quarantine or that threat function that we talked about previously. And all of that's automated through the open APIs. So when we've talked about Cisco DNA Center and policy before, one of the very first things that comes up, what about interoperability? I don't use your radius server. I don't use ICE. What about Aruba? What about Free Radius? With the access control app, we now have the capability to allow the third-party radius server, whatever it is, to assign what we call the scalable group. So through normal standard radius VSAs, vendor-specific attributes, we can allow them to assign the group. And then when that happens, whatever the edge is, wired, wireless, VPN, it then sends what's called an accounting request to the access control app, and that triggers a policy download. So anybody can authenticate the end user, and anybody can participate in the ecosystem because the entire function of the ecosystem, including the information sharing protocols, are all open. As I like to tell people, I literally have no idea how to make this any more open than going to the competitor and implementing it for them.
So the identity object lives in ICE, or in this case, a third-party AAA server, which probably is AD in the back end anyway.
Yep.
And then, but your policies that you're going to use to actually implement some kind of microseg is in DNAC.
That is correct.
That's why we can get away with a third party. Again, I'm just kind of going through it to make sure I got it straight.
You have it absolutely right.
And so the impetus to do that with the third party was, I'm assuming, because you're seeing that out there. I mean, ICE is I would consider that.
Yeah, ICE is the number one, radius authentication engine on the market. But the reality is that even with 55% market share, we still have 45% of the market that needs to be served, especially in some, European environments with eduroam. Free radius is very, very popular. So we need to respond to that in order to get the adoption we want with Cisco DNA Center. So we need to support that. And then that also fits into the generalized notion we have with security. I don't know if you guys ever talked to any of the security business group, but and you'll see at the end in the summary, we all are promoting simple, open, and automated because we realize that you go and you talk to a large bank, you talk to a university, you talk to anybody. They've got anywhere between 5 and 17 different quote-unquote IT security vendors in their IT security architecture. And we would love to be in every single space that we are, but typically we're not. Even when we have a very large install base with security in a customer environment, we're not everything. So we have to have a way to simply integrate. And I believe now the PX Grid ecosystem, where we do have our competitors, Checkpoint as an example of a firewall competitor, as a certified member of that ecosystem, we have roughly 120 ecosystem partners. And this is feeding that ecosystem so that you can have the native controls in the software-defined access fabric, as well as SD-WAN and ACI, but at the same time, we have to acknowledge that we need to share this information outbound.
And because it's just an identity object and really not doing anything else, there's no like functional hit, correct? If you're using a third party.
That is correct. Right. There's no functional hit if you're using a third party. It's an object. That's a great way to think of it. And then that object triggers intent-based policy for security. Now, one of the things that we're focused here on security, but that intent-based object is going to also trigger other kinds of policies that you might drive in your environment. Intelligent routing as an example, quality of service. It's one attribute in those quality service and routing decisions, right? It's not the entire component because, like with software-defined WAN, you want application latency and application response time to be part of which direction you think. So you might have an identity-based policy that says go left, but because application performance on the left-hand link is suboptimal, you still might go right. So it is one of the objects that we're building into the software-defined network. So with
back one there.
Yep.
So what if I have third-party switches as well, or third-party different wireless vendor and not Cisco?
Okay.
How deep and how well into this can I go in those situations?
In those situations, basically, you would be, let's take a third-party wireless because it's a simple. You would be what we would call a subtended node or an extended node in the environment where you can use whatever the third-party radius is to assign people into what would be traditional radius attributes VLANs, right? And then once you come into that VLAN, though, that VLAN now represents some sort of identity object in the policy definition inside a DNA center. So we can extend that down even to different third parties. As an example, we just demonstrated that with a Meraki AP. The Meraki AP is not fully participating in the software-defined access fabric, but it participates, signs people into VLANs. They are now part of the security policy object and the security policy itself.
Does that mean that no matter what we're doing, we're always going to have the LDAP server as our single source of truth, right? I guess that's kind of a weird question because that's what we all do anyway. But I'm throwing it out there for MDM and non-domain.
I would say when you're talking about a static attribute like a username and password, you're going to use your traditional mechanism, Active Directory LDAP. Now, one of the things that the Identity Services Engine, which is running this other aspect, is it's multiplexing multiple attributes to define this classification for security policy. So one of the things that, as an example, Cisco IT has is a concept of managed user, managed asset, trusted app. So I want a trusted user, trusted asset, trusted app. Well, they derive the notion of the user off a username and password. In US DoD, you would use a CAC or PIV card, right? But trusted device comes out of MDM. It comes out of normal SCCM. It comes out of normal tools like that. And so we're aggregating those things together to make a declaration. Are you trusted user, trusted asset? And another thing you look at is that threat intelligence feed. We look to say, is it a known entity that already on maybe some other part of the network has been defined by Talos as a untrusted device, as a threat? Well, then that goes into the policy decision, and we immediately put you into quarantine. We don't even let you into a normal group, as an example. So, yes, you will still use LDAP, Active Directory, the normal user credentials, if you will, but you're going to augment that with a bunch of other attributes.
And a lot of those other attributes are all going to live in ICE, those conditions and those, of how to identify, OID of your, is it an iPhone, things like that, like we do today.
Well, it's going to live wherever you think it is best served for the environment. So let me give you an example of what I mean. So if you need to go to AirWatch and say, what is the declaration of trust? Because you think AirWatch does that better than anybody else, we're going to go there and we're going to ask for their view of the statement of trust, and we're going to bring it back, and that's one attribute that we're going to use. So if you want to outsource those things, you can outsource them to whatever the statement of trust is. If it's a threat response or a vulnerability analysis system, Rapid7 or Tenable, we'll go there and say, give me your view. And then through policy, we'll say, yeah, Rapid7 says it's good, Active Directory says username and password, MDM says trusted, then we'll give you a trusted asset kind of tag.
When you say we, you mean DNA Center?
Yes. Just to be clear.
I'm tracking with you, but I want to make sure.
Absolutely. Right. And I am moving through, a relatively complex, set of ideas. If you're not familiar with it, sometimes it takes once or twice.
I think it's also important to remember that, and I work for a national VAR, and so we're doing big refresh projects of hardware, and we've been chatting about it. But I haven't personally worked with any customers running any kind of SDA environment yet. So for us, it's not emerging tech because we get it.
Yep.
But it's still evolving in our customers' eyes, and so I think the difference between like Cisco presenting, I don't use DNA Center yet.
Yep.
And I heard many presentations. I get it. Play with dCloud, things like that. So that's why I track with you, but I still want.
I am on board. Yeah. One of the interesting things about this is all of the components that I'm talking about can be consumed in a packaged form factor. So in many of the things that I've talked about open integrations, we have parts of ICE being used in that open integration environment. We think in order to lower operational expense that we need to move people as much as possible to DNA Center for automation, DNA Center for firmware management, and then software-defined access if you really want a scalable way to do segmentation. And as I think you talked to Victor earlier, stitching SDA and SD-WAN is how you get scale out of that virtual network and that VPN kind of construct that can be extended across any environment at a global level. And so this is what we're shooting for. Now, what access control app really is these four different buckets. The first is an enhanced policy experience. So if anybody has actually used dCloud and DNA Center, the policy experience, and I'll show you this in a second, dramatically different, primarily because of this man's tireless efforts of trying to improve the user experience. But then it also has more options to make it more realistic for deployment for security operations in particular. It also is the baseline for integrations between, not only with ICE, but it's the starting point for integrations with application-centric infrastructure, Cisco ACI, as well as going forward with SD-WAN. And then it is an open implementation. So in the past, this was the view of what a policy definition for access control would be. And you got a name and a status, right? What was it? Is it deployed? Was it modified and waiting to be deployed? Whatever it is. Didn't give a lot of detail about what was actually happening. This is the new view. This is the default view. It's called a matrix view. It is something that we brought to us from the identity services engine, but we've enhanced it so that it is much more usable. So in a glance, what you can get out of this is basically, do I have a policy between developers and BYD? It's empty, so I don't. If I have a red object, it's a deny, an explicit deny between different groups. And then we also have, blue indicating an explicit permit, right? In addition to that, we've made it scale very well. So it's this on the left-hand side is a zoomed view. And if you have a very large number of groups, which we do, we have customers that have deployed, over 5,000 different groups, doesn't, make itself usable on a single screen. So what we've developed is a way to basically have a hover over, like a magnifying glass, and you zoom across the different parts of the matrix to find what you want. There is a filter capability, I believe, up in the upper right in that tab, so that you can actually do a smart search. So if you only want to see one relevant part, you can do that. In addition, you can quickly hover over the box, get a definition of the actual what we're called contracts, if you think of a contract as an access control list, and then you can actually double click on it, and get the detail. And one of the things that if you've used ICE or if you've used our traditional products, what's different is rather than this being free-form text, it is now actual objects. So we've moved into the 20th century, as it were. But it gives you the detail of what you can do. One of the things that's different about the policy definition in Cisco DNA Center versus other products is we are not trying to be a default whitelist. So a default whitelist means that there is nothing allowed in the relationship until explicitly allowed. By default, we have it as permit, and then we give people the ability to put in denies. And this is primarily because we've had that cheap, fast, ubiquitous connectivity. Lateral movement happens all of the time for very good business reasons, as well as nefarious reasons. If we had gone in, and this is something I have from experience, and had a default deny as the starting point, it would never get deployed. There's just too much. And then you go and you go into a medical environment and you say, oh, please give me the network profile of your MRI machine. And they're like, I have no idea. I'm a tech operator, an image operator from background. So I'll go to my vendor and I'll ask my vendor of the MRI machine, what's the network profile so that we can build a security profile. And the network vendor literally will say, I have no idea. I bought some libraries and whatever that library's network profile is. So you literally have situations where you don't have it. So one of the things that we're building on top of this platform is the ability to do what we call policy analytics and modeling so that we can discover those protocols and give you a proposed policy between different groups. There's another view. This is, I actually have this live if you want to see it, but instead, if you don't like the matrix, you can swap it over to a traditional list view like what most firewalls run off of, and you have the same kind of policy definition, source to destination. You have the same kind of detail of the ACL. Nothing too exciting there. We also have guided ways. One of the things that we found in our usability research, in our UX experience research, is that people often, didn't realize what they were doing when they were expressing their intent. And so we have now given them a guided summary through the environment. And for whatever reason, as an old school ACL guy, CLI, people love the ability to grab one of these buttons or one of these bubbles, drag it over to the source, drag it over to the destination, so drag and drop, if you will, and use that as the way to create contracts. We have some very definite data that people far prefer this to drop-down lists or anything like that. So it's interesting, so we have it. So we basically have a guided authoring policy, and that allows us to then go through, define the relationships between source destination groups, and select what we call a contract. A contract is just an ACL. That's all it's really doing. And what we do have is embedded information about references. So one of the things that often frustrates people inside of many different policy managers is they never understand how much a particular classification is referenced. So we actually tell you that there's 21 policies that are referencing it. We tell you what virtual network a particular security group lives in. In addition to that, we also tell you all of the different contracts that are referencing the different groups. And so one of the things that you heard about earlier was multi-domain. So this is an example of inside a DNA center, we are creating a group, and then that is getting automatically populated into the application-centric infrastructure controller, APIC, and these are pre-pended or post-pended, with the definition SGT, so that you know inside of the ACI controller immediately that they came from Cisco DNA Center. Likewise, if DNA or APIC controller would create any of these what are called endpoint groups, database, things like that, they would automatically be imported into DNA Center and also, again, post-pended with the designation EPG so that you know immediately that its origin is from APIC. In addition, you have no capability to edit that or delete it because you're not authoritative in Cisco DNA Center, ACI is. So it gives us referential integrity for it. So we can bring it automatically out of DNA Center. And then this is an example of scalable groups and how many policies are associated to it. One of the things that for anybody has used ICE is ICE has been used for this policy function in the past. You'll see here that it is just free-form text. You can fat finger that. One of the things that we've been asked for is the ability to migrate that policy from ICE into DNA Center and convert it from text to data models. So this is actually a model-driven function, and there's no ability to have CLI mistakes as an example. And so, in the definition, in the interest of time actually, this is just an example of the access control apps. So in summary, let's get through there, what we're trying to do with the access control app, and this is just the start, this is one of several phases, is we're trying to make intent real for security. In all seriousness, one of the things that really excites me about being on Cisco DNA Center is the ability to have assurance. And when I mean assurance, I'm not talking about the connectivity or DHCP response. It's the ability that I can generate telemetry out of the network infrastructure, wired or wireless, and I have a place to collect it and start reporting on it. So the very first thing that I thought when Dave was presenting to you was, okay, why isn't this person working? Well, he was showing you a bunch of network level telemetry. Well, what if the reason that the connectivity isn't working is because it's a policy-driven issue? So that ability to marry both the network telemetry with the policy telemetry to give you a single answer from a single spot, regardless of whether it's security operations that has created the situation you're looking at or network operations, that's the real power. We're the core to enabling multi-domain. As I showed you, we have ACI integration. We will shortly have SD-WAN integration after that. And the personal mantra and something I use a lot since I'm one of the primary people opening up and defining the definitions in the community is to have this be simple, open, and automated.